Alright, and this is video 2 for week 8. This video is going to be rather short. We're just going to introduce a little bit of notation. The notation that we're going to see is that if we have an n-dimensional input for a function, we can talk about the gradient of a function, and we write this as this upside down triangle. And if you are programming in LaTeX, the command or the syntax that you use is going to be slash and then nabla. Okay, and then we just write this symbol and say, well, it's just really the partial derivatives of f with respect to each of the variables that we have. Okay, so for example, here, if I write that nabla f, okay, I believe this should just be, well, 2x and then e to the z and e to the z. Oh, I forgot the y. It should be y e to the z in the last component. Okay. Similarly, well, if I have just a general function here, I don't have a rule necessarily, right? But if I do the gradient of f, I believe this is just going to be whatever f is with respect to x, so the partial derivative of f with respect to x, and then the partial derivative of f with respect to y in general, and then it would be f with respect to z, or partial derivative of f with respect to z, etc. in more dimensions. Okay, and there is something nice about this. If we are looking at that h of x, and well, it's kind of cumbersome notation, right? We can actually just write this as, well, we can't change that point, but we can write the point, and then notice that we just have the partial derivatives, right? So I could just say that this is plus the gradient of f at AB, and then dotted with vector x minus vector a, okay, just for shorthand notation. Okay, so and this actually is kind of, and if I think about this a little bit, here's my thought bubble. Okay, this looks a lot like that L of x is equal to f of a plus f prime at a times x minus a, which I saw in Calc 1, right? So there's that kind of connection here between each of the components. Just now, instead of working with one variable, we're working with many variables. Okay? And that's the end of this video. Next, we're going to keep talking about differentiability.